Good morning, Chem 20s. Our lesson today is going to be a review lesson on scientific vocabulary. In science, there are two types of scientific knowledge. There's empirical knowledge and there's theoretical knowledge. Empirical knowledge is when we use one of our five senses: sight, sound, touch, smell, or taste. These are usually gained through observations. Theoretical knowledge, on the other hand, is knowledge that is abstract. We explain or describe these observations based on ideas we can't actually see. We're going to interpret what we actually are coming up with based on something other than our five senses, whether it be past knowledge or past experiences, or possibly what we were told or learned in class, but we actually didn't see or experience for ourselves. So if we take a look at empirical knowledge tends to come from observations, one of those five senses again. So this is a direct form of knowledge. For instance, if we go into the laboratory and we get the electronic balance and we weigh something out on the electronic balance, we are going to get a mass or a reading. This would be an observation. I can physically see the mass of an object when I weigh it on an electronic balance. This is no different than, let's say, I mix two chemicals together and I waft. I can get the smell of something. That's an observation. It smells sweet. It smells pungent. It smells like strawberries. Observations can also be broken into two categories: quantitative observations or qualitative observations. Quantitative observations means exactly what you see hidden in the word, a quantity. This value is going to include some sort of number or change in a number, like a change in temperature. Other examples might be, hey, looking at the picture, I can determine how many numbers of beads there are. So it's going to come with a quantity. Or maybe I weigh the beads, so I'm going to have a mass of the beads. Qualitative, on the other hand, is something that we describe. It is going to be, like the word says, a quality. This quality could be, let's say, a color: red, green, white. It could also maybe be a shape of an object, like it's square, or it's round, or it's hexagonal. That's screwed up that word. Well, those were empirical. Theoretical, remember, that's what you get from interpretations of things. An interpretation is an indirect form of knowledge. So if I look at the example NaCl, on its surface, it's just NaCl, it's some sort of chemical. However, based on previous knowledge, based on something else, you can know that NaCl is actually sodium chloride or table salt. You could zoom in on it. Now, not with your eyeballs because you couldn't see it, but you know that NaCl is made up of a tiny little bit of cations and anions that make something called a crystal lattice. So here's the table salt you would sprinkle on your corn on the cob. But if we zoomed in and used previous knowledge, we would know that it makes a crystal lattice. And this crystal lattice is made up of alternating sodium ions and chloride ions to make something called sodium chloride. I can't see the crystal lattice with my eyeballs. I also can't zoom in and see the little Na positives and the little Cl minuses. So this is something I'm building on from previous experience. Now, the nice way I like to use to remember these new 6 words is I like to break down empirical, theoretical, observation, interpretation, qualitative, and quantitative into this diagram. So knowledge is often broken up into 2 categories. There's theoretical knowledge, which is dependent on, or comes from interpretations, and there is empirical knowledge that comes from direct observations using your five senses. Those five senses can get you quantitative observations, observations that include numbers or numerical values, or observations that are qualitative, those observations that describe qualities like a color. So what I would like us to do is let's practice this. So if it was me, I would pause the video. I would determine where these 5 statements in purple belong. Are they observations or interpretations? And I would place them under the correct category. Then unpause the video to check your answer with me. Pause now. So the reaction took less than 20 seconds. Well, sounds like I'm using one of my five senses to figure that out. And so that would be an observation. The white powder is a solid. Looking at this, this would be a powder, it would be white. This would be an observation, not interpreting anything on this. Again, this experiment, I don't know if you noticed when you were reading through the five, this would be the perfect experiment of a volcano in elementary school. So we are mixing baking soda and water. We're going to make the bubbles. We're going to go whoosh, and it's going to be wonderful. Little kids like to do this all the time. Sometimes they even do it out in the snow. They make a little snow volcano. So the bubbles produced are carbon dioxide. Well, there's lots of things that produce bubbles. There's lots of different gases that are bubbles. So unless I have previous knowledge from this experiment, there is no way I would be able to say that they are carbon dioxide. They could be nitrogen dioxide or sulfur dioxide or even oxygen. So I'm going to put those over here in the interpret category. The clear liquid is an acid. Again, I'm just mixing a clear liquid with a white powder. So unless I have previous knowledge of that, I would completely put that under an interpretation because I would have to know that that clear liquid is not only is it an acid, but what type of acid it might be that would also fall under interpretation. There's lots of clear liquids. Water is a clear liquid, hydrogen peroxide, all these sorts of things. So that vinegar, although it's an acid, we can't tell it's that because they didn't say anything about smelling it. So interpretation. When mixed, bubbles were produced. This one, again, kind of like this one is bubbles were carbon dioxide. This one didn't say what the bubbles were. They just said, hey, there are bubbles. That would be a direct observation. That would be a site observation. So hopefully you got those five statements correct. Now, what I want to try again is this time, let's see if we can figure out qualitative, quantitative. So again, pause the video. You decide which category these looks like 10 are going to go, and then unpause the video to check your work. So temperature. I would think most of you would have put it under quantitative. Now, this is a good discussion on being specific. One word answers are not going to work in this course. So when I talk temperature, I would think most people would say, hey, 15 degrees Celsius, 52 degrees Celsius. However, we could also, maybe an elementary kid would describe it as, ooh, the porridge is cold. The porridge is warm. The porridge is just right. If we were describing it that way, we would put it under qualitative, but I would assume most of us would go 20 degrees Celsius, so it's got a numerical value. We would put it under a quantity or quantitative. Length. Length probably for most people is the distance to grandmother's house is 25 kilometers. The length of the piece of wood is 4.2 meters. So again, I would put this under quantitative. pH. It could be the pH is acidic or the pH is basic. That would be qualitative. Or again, it could be the pH is a pH of 3. The pH is a pH of 14. So again, being general doesn't work for this. You want to be specific and use your language. So I could say the pH is acidic and throw it on this side. However, I believe most people probably said the pH is a pH of 3 and put it over in quantitative. Volume. Volumes you might know might be, hey, the milk jug had 2 liters of milk. We're measuring 125 milliliters of water. So I'm going to put it under quantitative. Physical state, is my substance a solid, a liquid, or a gas? I guess the other option is it aqueous? So physical state would fall under qualitative for sure. I'm going to skip density because I'm going to assume most of you skipped density and left it till last. So odor, it smells sweet. It smells like strawberries. It smells awful. Oh my goodness, why did I smell that? I would think most of us put odor under a qualitative observation. Mass, again, one of those that could fall in both categories. The substance was light, like a feather, or oh my goodness, that thing was very, very heavy. I would think, though, most of us probably said, hey, the mass was 40 grams. The mass was 98 kilograms. Texture, smooth or rough. So I would think that would be qualitative. Color, the color is red, it's orange, it's blue. I would think most of us would put it here under qualitative. However, again, it could be quantitative. If you have ever bought paint, I remember having to repaint my back fence. I went to the paint store. I was just driving by. I had been to it 4 years earlier when I originally bought some paint to paint my fence. So I stopped again and I'm like, I need some white paint for my back fence. And they went, well, what color? I said, white. They said, what color of white? I'm like, just white. Go in the back. Don't put anything else in it. I want white. And again, there was a problem. They just were like, well, there's shades of white. So I'm like, okay. I drove home. I came back, showed them the old can because I had a little tiny bit in the bottom. They're like, oh, white, 2351. Yes, white 2351. So I guess it could be quantitative. Again, somebody like Miss Grover in the art department, she would certainly have a wide range of reds and blues and greens that she would know. And my guess is on a computer screen, they are even probably numbered of what percentage of red and blue and green makes up certain colors. I'm basic, so to me, a color is red, it's blue, it's yellow, it's green. I put it under qualitative. Density would be like you did probably in grade 8 when you did Archimedes' principle, when you saw objects floating on one another. So the density is lighter than another object. This density is heavier than another. So if you think of it that way, you could put it under qualitative. I think of density kind of like the formula. It's grams per milliliter. So a density of 1 gram per 1 milliliter is the density of water. It's numerical. So I'm going to put it here. Any value number that is smaller than 1 will float on top like styrofoam. Any value that is greater than water, greater than 1, would fall to the bottom like copper. So again, this is how I split them up, but I totally could see arguments for temperature and color and length and pH and volume and mass and even density to be qualitative or quantitative. So again, I want you to be specific and use your language if you had to come up with an example. Last one we're going to do. Please copy the table and then pause the video, and I would like you to determine in each statement, is it an O for observation, an I for an interpretation, an E for empirical, a T for theoretical, a qual for qualitative, or a quant for quantitative? Fill in the complete chart, then unpause the video to check your work. So the first statement said vinegar consists of 2 carbons, 4 hydrogens, and 2 oxygen atoms. So if I take a look, the formula for vinegar is CH3COOH. Again, I can't see this formula when I look at clear colorless vinegar. Instead, when I think about that, that would have to be an interpretation. I would need previous knowledge to know that that's the formula for vinegar. Because it's in interpretation, it is also theoretical because, again, I'm using past knowledge. And again, it looks like I know that this formula has 2 carbons, 4 hydrogens, 2 oxygens. So that would be quantities. So it would be quantitative. When I'm mixing the vinegar and the baking soda, it's the same experiment again. You can see the kids up in the corner. Bubbles are being produced. Well, I can see a bubble. So that would be an observation. I'm using my sight. That then would mean that it is an empirical quality. And because there's bubbles, all I'm saying is I see them, not how many there are. This would be a quality. Now, when I go to do this experiment, we're going to drop in roughly 2 milliliters of a white powder as my reactant. So one of my 2 reactants is going to be 2 mils of a white powder. Again, I can see it's roughly 2 mils or approximately 2 mils. I can see it's white, therefore it's an observation. I also believe that it is empirical because, again, using one of my senses. And I do have a number attached at 2 milliliters roughly, so I would say that that's a quantity. The experiment reacts to produce carbon dioxide and water vapor. Well, since it's producing carbon dioxide, again, it's a gas. I don't know for a fact that that gas is carbon dioxide unless I came with previous knowledge. Same with, I don't know if that colorless solution that we're producing is water vapor, that the gas that's escaping is also water vapor. So I would say that that is an interpretation. I would also say then that it's theoretical because they tend to pair together if you check back to the chart. And again, there are no quantities here, so I would say this is qualitative. Hope this clears up your 6 vocabulary words: observation, interpretation, empirical, theoretical, qualitative, and quantitative. We are now going to use these vocab words throughout the rest of many lessons in Chem 20.